is a definite integral, the first thing I do, I have to check that f of x is continuous. If f of x is not continuous, I'll say the fundamental theorem of calculus is not applicable, and I move on to the next problem. But it happens that this function is undefined only at -1/5, and -1/5 is not in the interval. So then the function is continuous on 0, 3. I will say let y be 5x plus 1, as long as dy is in the problem. Very close. Multiplying and dividing by 5 never hurt anyone. Not any function anyway. Okay, so then at this point, be very careful. Do not copy the limits of integration. Not yet. So all this is our dy. The denominator is y, but now the limits of integration are refer to variable x. I cannot copy 0, 3 for a new variable. What I can do is replace x by 0. 5 times 0 plus 1 is 1. That makes the lower limit for y. And I can replace x by 3. 5 times 3, 15, plus 1, 16. So this is basically not only the only difference. So there is no need to go back to the previous variable. The answer will be a number. It doesn't matter if you calculate it in y or if you calculate it in x. Please don't go back. If you'd like to go back and consider this a indefinite integral and so on and so forth, you can. It's up to you. I wouldn't. So this is 1/5. This is natural log of y from 1 through 16. I plug in 16, I get natural log of 16. Minus when I plug in 1, I get 0. And this is it. There is no need to go back to the previous variable. What is absolutely necessary is when you write the integral in x and it has limits of integration 0, 3, and you move to the integral in y, you have to have new limits of integration. That is absolutely mandatory. For that reason, I highly recommend don't go back. You'll get the same answer no matter what. This is how we applied the substitution rule for definite integrals. Any questions on this before we move on to another example? Any questions? Anyone? Okay, moving on to the next. The integral from 1 to 2. The numerator is e raised to power 1 over x. The denominator is x squared. And of course, dx. Anyone would like to give it a shot of a substitution? And I'll sip some water in the meantime. Anyone? What bothers you? I know this is not a scientific way of finding the substitution, but it's a memorable way. This is what bothers me. This function inside e to the x. As long as I meant dx, as long as dy is in the problem. Is dy in the problem? Of course it is, with a minor adjustment, which is not a problem at all. Multiplying twice by -1 will not change anything. So then the new integral becomes negative outside. Do not copy the limits of integration. So this is e to y And this, with the minus in front, negative, dx over x squared is dy. Okay, so I forgot to say, but I already checked in my mind, this function is undefined at 0. 0 is not between 1 and 2. So the function is continuous. So when x is 1, y is 1 as well. When x is 2, y is 1/2. Okay, then. Negative e to y from 1 to 1/2. Minus outside. When I plug in 1/2, I have the square root of e. Minus, when I plug in 1, I have e. You can distribute if you want, so it's e minus the square root of e. Any questions here? Any questions? Okay, so let's look at the integral from 1 to 2 from x, the square root of x minus 1 dx. Don't be afraid to start on a path, and if it doesn't work, it's okay. You go back and you change the substitution. You may not have picked the correct substitution from the very beginning. It's okay. It's okay to give it a shot. So what do you think we should choose this time?
X minus 1.
Exactly. So let's use u this time. As long as du is in the problem, yes, it is. So careful now. So there is no problem. This is my du. I know that this is the square root of u. So that's no problem. I do have an unaccounted for x in front. Is there anything I can do about that? So I will have the integral. First of all, when x is 1, 1 minus 1, the lower limit for u will be 0. And when x is 2, 2 minus 1 will be 1. I do have the square root of u, and I do have du. But what do I do with this? I cannot leave it behind. I cannot forget about it. I have to replace it. Is there anything I can do to replace that x? In terms of u, of course. Any suggestions?
Can you change it to u plus 1?
Exactly, I have to. I will solve this equation for x. So it is u plus 1, of course. X is u plus 1. So now everything is accounted for. All I have to do is just distribute here. It's not a big deal. So u to power 1 times u to power 1/2 is u to power 3/2 plus u to power 1/2 and du. Do not go back to the previous variable. There is no need. So I distributed multiplying u by u to 1/2, and I got copy the base and add 1 plus 1/2. And then 1 times the square root of u is u to 1/2. I have to find the antiderivative and then plug in the upper limit and the lower limit. And this is it, in the sense that it's almost complete. So u to 3/2 plus 1, 5/2 over 5/2 plus u to 1/2 plus 1, 3/2 divided by 3/2, everything from 0 to 1. I like it because I don't have to plug in 0, and when I plug in 1, it's just 2 over 5 plus 2 over 3. The least common denominator 15, this one needs a 3 and this one needs a 5, so 6 plus 10, 16. Since it's a number, you don't need to go back to the previous variable. I strongly recommend do not, because you have to write this anyway. Once you go from x to u, you have to write this integral anyway, and you have to find the new limits of integration, and then why go back? Any questions? Any questions? Okay, here's another that caught my eye. I think it's e to the fourth. Let me take my glasses off and see, make sure that it's, yes, e to the fourth, yes. Dx divided by x, the square root of natural log x. Okay. Let's give it a shot. Sometimes there is more than one substitution that works. Sometimes we have to find the correct the best substitution, or the only substitution. What would you like to try? And then I'll tell you what I would like to try.
Y equals ln max.
Very good. This is what I would like to try. As long as dy is in the problem. Of course, here it is. Dx over x. This is my dy. And this is the square root of y. Everything is accounted for. Do not copy the limits of integration. So I have dy over the square root of y, which I will change into y to negative 1/2 in a moment. But we have to establish the limits of integration first. When the lower limit is e, how much is natural log e? One. When the upper limit is e to the fourth power, the top is 4. So next step, we have the integral from 1 to 4 from y to negative 1/2 dy. So it's y to negative 1/2 plus 1, which is 1/2, divided by 1/2 from 1 to 4. And I flipped 1/2, I get 2. And this is the square root of y from 1 to 4. 2 stays outside waiting. The square root of 4 is 2, minus when I plug in 1, the square root of 1 is 1. 2 minus 1 is 1. 1 times 2 is 2. Any questions? Any questions? Here's another. I didn't say it here. I keep forgetting, but I just want to make sure it's clear. The function is undefined at 0. And for anything else, natural log, and for 1, of course, natural log 1. 0 and 1 are not here, so the function is continuous. So I look again, x to the 4th is continuous everywhere, sine x is continuous everywhere, I don't care what the limits of integration are. However, every time I see a symmetric interval, two things come to mind. Is the function odd? Is the function even? So let's look at the function. We've never seen a symmetric interval yet with the substitution or in general. So here's an example in which the interval is symmetric, and we're asking ourselves, is the function odd or even? What will you say? Is the function odd or even? Or none of the above? It doesn't have to be. So this piece is even for sure. What about this piece?
It changes sign.
Right. So this is odd. So then the entire thing is odd. So let me refresh your memory. The only functions that are even, trig functions, are cosine and the other function that has cosine in it and nothing else. Everything else is odd. So only cosine is even, and the other function that does not have anything else in it but cosine, which is secant. Everything else is odd. All the other four are odd. Sine, tangent, cotangent, cosecant. If a function has sine in it, if a pure trig function has sine in it, it must be odd. If it only has cosine in it, it must be even. So this is an odd function. What is the answer then? I'm digging my last lecture. I just dug up my last lecture from my recycling. So what is the answer? Anyone?
It's 0.
Excellent. Thank you. It is 0. Very good. Let's look at the integral from 0 to 1/2 from sine inverse divided by the square root of 1 minus x squared dx. What do you think?